Well, friends, it's very good to be able to welcome you to this event here in St Paul's Cathedral this evening. My name's Edward Carter. I'm the chair of the Christian Evidence Society, which is actually quite an old organisation. It was founded in 1870, which is quite a few years ago, of course. At the time in the 19th century when religion, faith, the Christian faith, was involved in an interesting dialogue with the rise of modern science. And there was a thought on the part of some Christians not to push this away, not to have faith kind of defeated by science, but to engage with it, to have a serious conversation. And it was in that spirit that the Christian Evidence Society was founded and became quite influential. There's a really interesting history, which I won't bore you with now. But there was, at one point in the early 20th century, a secretary of the Christian Evidence Society, the Reverend C.L. Drawbridge, in case you were wondering where the name of the Drawbridge lecture comes from. It could be a kind of, a drawbridge that somehow links two things, and that's a lovely image to have. But he was a real person and did an awful lot of work for the Christian Evidence Society. And in his memory, a series of lectures was founded in 1946. And these aren't exactly a kind of regular annual thing at all. They're an occasional series, and at different times they've taken different forms. We've had a few years not doing them for various reasons, and this in a sense is a new beginning, because what we want to put on tonight is an interesting lecture, yes, for us who are here, but also using the wonders of modern science and technology to be able to use what happens tonight further afield using social media and other ways, hence the cameras that are here tonight. But the main purpose, the heart of this evening, is for us all to be part of an occasion where we're kind of aligned with that founding spirit of the Christian Evidence Society, that sense of being in a space where a thoughtful and credible Christian apologetic or voice is heard. So a welcome from me, but I'm going to hand over now to my colleague on the trustee board, Gillian Strain, who's really done all the work to organise, and she's going to introduce our speaker tonight. But it's lovely you're all here, and a warm welcome to you all.
Thank you. I'd just like to add my welcome. Thank you for coming to this lecture tonight. My name's the Reverend Gillian Strain. I'm one of the trustees of the Christian Evidence Society. And my role here tonight is your Master of Ceremonies, your MC. So I will keep us all on track and let you know what's happening. So the structure of this evening, after Professor Gleiser speaks, he's going to be followed by the Reverend Dr. Andrew Pinsent to give a reply, a response to what is said. Then there's going to be a conversation between the two at the front here. Now, I've got lots of questions for our two speakers tonight, but what I'd really like is your input as well. Because we're filming this evening, we're not able just to take questions from the floor, but if you'd like to tweet me a question, I shall be keeping my eye on Twitter. So tweet a question, #Drawbridge2018. If you have a question, I'll pick it up and I'll try to slot it into their conversation. Now, in the popular imagination, religion and science are seen by many people as two magisteria, two bodies, two tribes that are in conflict with one another. And there's certain names, certain authors in this country that get an awful lot of airtime, telling you that the only way that science and religion relate is through conflict. And the Christian Evidence Society, as Edward just introduced, exists to put a different option, a better way we like to think of it, as coming into this field of knowledge, religion and science. And I was on a conference a couple of years ago. It was organised by CERN. We were on top of an Alp in Switzerland, and it was a science-religion conference looking at the role of logic in science and religion debates. And it was a good conference. There was a lot of the same stories, the same narratives, the same boundaries, the same stuff going on. But there was one voice that, for me, stood out, and that was Professor Gleiser. To me, he seemed to be saying something new, something different, something fresh into the science-religion dialogue, and something I felt needed a wider audience in the UK. So it needed to be heard to add a different way into our debates. So you can imagine when the other trustees of the Christian Evidence Society asked me to think of someone to come and do our Drawbridge talk, there was only one person that I wanted to come and give this talk to you tonight. So for those of you who don't know, Marcelo Gleiser is a professor of theoretical physics at Dartmouth College, which is in New Hampshire in America. He specializes in cosmology and high energy physics, complexity theory, and astrobiology. At the same time, he is director of the Cross-Disciplinary Engagement, ICE, at Dartmouth College, which is dedicated to transforming the dialogue between the sciences and humanities in the academy, so at university level, but also in the public square, very importantly. Both his undergraduate and master's degrees were from universities in Rio de Janeiro, in Brazil, where he's from. He did a PhD just up the road at King's College London, and today he is a fellow and general counsellor of the American Physical Society and recipient of the Presidential Faculty Fellows Award from the White House. And apart from all that academic engagement, he is also very active in that in the public understanding of science. He's written 4 books and many essays and lots of blogs, constantly challenging people, constantly translating the science so everyone can understand it. He's frequently in science documentaries and distinguishes himself as a scientist, humanist, presenting science within a broad cultural, historic, and philosophical context, exploring both his ancient roots, that historical grounding to what he says, and also the spiritual role in humanity's ongoing search for meaning. Marcelo, we look forward to your lecture tonight, Unknowns in Heaven and Earth.
Thank you all for coming. I'm very pleased because I know it's a beautiful sunny day outside and it's sort of difficult to kind of negotiate the bright light out and be inside here, but I hope that the words that are going to be said and the discussions we're going to be having will also illuminate you from the inside out, so to speak. So there is a complementarity there. So thank you, Gillian, for inviting me for this. I'm very, very pleased to be here. It's not every day that a physicist speaks at St. Paul's Cathedral in London. So it's a very unique event, not just for the Drawbridge Society, but for me as well. So what I want to do today is to give you a general overview of some of my ideas on the general field of science and religion. And let me start by talking about us humans. So to be a human is at once exhilarating and perplexing. It's exhilarating because we have the capacity to wonder. We are a very rare kind of animal. In fact, we're the only ones that we know of in this planet, at least. They are able to ask questions about existence, about life, about death, about where do we belong in the big scheme of things. And so this curiosity that we have has been a driving force throughout the ages, trying to inspire us to find answers. And we are very, very curious creatures, right? But it's also perplexing because a lot of those answers have a lot of those questions have no answers. A lot of what we try to do is come to grips with some of the things which are much grander than we are. And in doing so, we use our amazing creativity to develop ways of thinking, ways of feeling about the world, about ourselves, about our relationships with each other, with the world we live in, and of course with nature, right? Now, one of the problems that we have right from the start is that we are creatures that are aware of our own mortality. We know that we exist within the boundaries of time. So we're born, we grow up, we start asking questions about existence, and we also know, and it's very apt that we are here right now in this very location, that eventually our life expires, right? And this can fill you with many different kinds of emotions, from anxiety to kind of anticipation, depending what you think you're going to find afterwards. But the truth is that it is a very difficult thing to get to grips with. I mean, to understand what's our meaning in this world while we have this some number of decades, to kind of make sense of it all. So, and this is not a question that is new. This is a question that is as old as time. So even before religions, I'm sure our ancestors, the hunter-gatherers, they're going around the world looking for food. They were also in awe with existence. They're also curious about who they were. Nowadays, we have anthropological evidence that Neanderthals buried their dead, had music, and also created some primitive forms of art. So this need to express ourselves is much older than the age of civilization as we know it. And of course, once you start looking at the world we live in, and of course our ancestors were very much connected with the world, the natural world, in a very different way than we are today, especially in a big city like this one, you realize that there are two fundamental aspects of nature which are different. One is there is a periodicity in things. Things tend to repeat themselves. You have the day followed by the night, so the cycle of 24 hours of night and day. You have the seasons of the year. You have the tides that come in and come out. So there are repetitions, there are patterns that we see in nature, and they of course have seen in nature too, and learning about those patterns was absolutely essential for their survival. They needed to be able to predict when it was time to go hunting, when it was time to plant, when it was time to harvest. So this intimacy with the cycles of the natural world was extremely important. But on the other hand, nature is also ruthless. Nature can kill, it can destroy. You can have storms, you can have hurricanes, you can have volcanic eruptions. And these are not cyclic. These are things that just happen. Right? And people felt very powerless with respect to that. So very early on, nature became a portal, so to speak, to a way of communicating with forces which are much bigger than we are. And there was a lot of mystery in the not knowing what was going to happen. And so, before the organized religions, you had animistic religions that dealt with the god of fire, the god of volcanoes, the god of water, the god of rain, because those were an attempt for people to find a way of communicating with the unknown. And every tribe, every group of people that related to nature in this way had a translator, a shaman, a holy person, that was in a sense someone that would have the ability to understand or interpret the ways of the gods and translate it to everybody else. And ritual was a way of expanding this behavior so that we could have a common dialect between us and nature, controlled by the gods. So at the very core of many religions, there was this need to have some sort of power, some sort of control over the natural world, which was so mysterious, and it could be so rewarding, but it also could be so destructive. And this is a very important point, that this sense of mystery and the sense of awe is not something new to humanity. It's something as old as we can think of. And we have always been dealing with these same questions. What's really interesting to me is that the questions that we ask now about our origins, where do we come from, what is our place in the universe, are questions which are very, very old indeed, and they have found many different kinds of answers through the ages, right? And so when you talk about Einstein, for example, just to give you an example, he has a very famous saying, which is something like this: what I see in nature is a magnificent structure that we comprehend only imperfectly, and that should fill a thinking mind with deep humility. So what he's saying here is something very profound. He's saying that, look, there is the world out there, right? We are not into solipsism that believe that everything is inside your head. So there is a world out there, and we are going to try to comprehend this world, to go into the mystery of creation, so to speak, knowing that we can only see so much of what's going on. And because of that, we should have a sense of humility when we deal with all the mysteries that we don't understand. And there is so much that we don't see. You know, we tend to, in our everyday lives, we tend to sort of deal with reality through our senses, right? So you can see me right now, you can hear me with this interesting echo going on, you can feel the warmth inside the room right now. So you create a sense of reality based on your perception of what's going on, which is really a sensorial perception of what's going on. And you may say, yep, this is the world, this is reality. But the truth is that this is a very tiny fraction of what's really going on right now. For example, right now, all of you are glowing in the infrared. If I had infrared goggles, I would see these beautiful spots of light because you're all glowing at about 98.6 degrees Fahrenheit, unless you have a fever. I hope you don't. It could be a little warmer than that, and there'll be even more powerful glow. But the point is that there are aspects of reality that escape us in this initial view of what's going on. And so what we have done, well, we have tried to amplify our view of the real. And science is one of the ways in which we do that, right? And it is really important to understand that when we talk about science, at least when I talk about science, I talk about it as a narrative that we construct to make sense of reality, you know. And as I'm going to argue as we move on, the point here is that there is no final truth about the way we see reality. There are only approximations to the truth. So, you know, the wonderful Argentinian writer, Jorge Luis Borges, he wrote a short story about map makers. And the king wanted them to make the most perfect map they could of their kingdom, right? And the map makers put tremendous detail on pieces of paper. But of course, every time you put the whole world into a piece of paper, you're going to miss something. So they kept expanding the size of the piece of paper and expanding the size of the piece of paper and putting more and more details until the map was as big as the territory. And then it was a perfect map. And of course, you can never do that, right? I mean, you can always create a map which is an approximation to what we see of reality. And science is very much like that. It's in a sense a map of the real world. And because of that, and because it's not as big as the real world, because we can't even see the real world completely, we're always going to have an incomplete map of the world. This is a very important point. And furthermore, there's another set of words from Heisenberg. So Heisenberg, the German physicist, was one of the architects of quantum mechanics, you know, the mechanics that describes the behavior of the atoms and of subatomic particles, extremely important. A lot of our modern technologies, you know, depend, every time you see something digital, it has to do with quantum mechanics. And he said something very important. He said that what we see of nature is not nature itself, but it's nature under our methods of questioning, which is a very important point, which means that we humans are asking questions about nature, which are very human-like. And because they're very human-like, they're not final questions. They are imperfect questions. They're fallible questions. They're things that we construct to make sense of the world in the best possible way. But we should always keep in mind that that's all there is to it. Unfortunately, you know, a lot of my colleagues get carried away with the success of the scientific method, which is indeed tremendous, right? I mean, we have done some quite amazing things. Just to give you an example, if I'm not mistaken, this cathedral was designed by Sir Christopher Wren. And in the 17th century, Christopher Wren, Robert Hooke, another physicist, and Edmund Halley went to Newton in Cambridge because they suspected that the law of gravity had something to do with the inverse square of the distance between two bodies, but they couldn't prove it. So they dispatched Halley to Cambridge to talk to Newton, because Newton at that point was a recluse. He didn't want to have anything to do with people. He had some disputations actually with Robert Hooke. You know the famous saying that says, if I've seen farther, it's because I was standing on the shoulder of giants? Well, that's because Hooke was almost a dwarf. and he was making fun of Hooke. So it's not because he was being very magnanimous about anything. Anyway, when Haley goes to Newton, he says, you know, we have this idea, but we can't prove it. So Newton said, hold on a second, let me go. I think I have some notes about this that I wrote a long time ago. It was like 1660 something, 67, when he was very young, during the plague. So he came back and said, well, I actually can't find this, but give me a few days. So in a few days, he sends a 10-page manuscript to Haley with the skeleton ideas of the 3 laws of motion and of gravitation, where indeed the attraction between two masses go with the inverse distance squared of the masses, right? 1 over r squared, the famous law of universal gravitation. And then he said, and when Haley receives that, he is blown away. Because, you know, people have been trying to figure it out forever, and Newton in a few days just scribbled the answer like that and says, you have to write a real book about this. You know, and Newton said, I can't afford it, because in those days, you know, you had to pay for a book to be published, and you had to work very close with the printer. And Haley said, I'll pay for it. And Newton said, okay, I'll write the book. So he writes the book, which is one of the most fundamental, most important books in the history of civilization, which is called The Mathematical Principles of Natural Philosophy. Note the title, The Mathematical Principles of Natural Philosophy, where natural philosophy is the name for science. Right? Until the mid-19th century, that's what we were all called, natural philosophers. And anyway, in that book, which changed the way we think about the universe, there is a quote at the very end, it's called the General Scholium, so it's sort of like an epilogue of the book, where he talks about the nature of gravity. And the problem was the following, that the sun attracted the earth, and the earth attracted the moon with some force that was coming down, as he said, 1 over r squared. The problem, though, is that that force seemed to propagate in space like some ghost. It's called an action at a distance. And instantaneously, so that if the sun exploded, the earth would be gone, so to speak, immediately, right? And Newton was very bothered by that. So he writes in this book something that became very famous. He says, you know, as to the nature of the force of gravity, I feign no hypothesis. And I leave it to the discretion of the reader to figure this out. Meaning, he did not know why masses would exert a force against one another with that particular strength, but his description of gravity worked, and it was good enough to describe the orbits of the planets, the orbits of comets. Then he predicted, for example, that Halley's comet would come back every 76 years, and the tides and a series of other things with that powerful theory. But he did not know why gravity acted the way it did. And this is a very important point, because that is exactly how science works. Science describes natural phenomena by making a series of assumptions, which are then tested against observations. And if the thing works, your model is excellent, and you just keep pushing it. And science is always pushing until things break down. And in case of Newton, you know, the success was so tremendous that it sort of ushered the whole Enlightenment, the idea that reason can explain everything about the world, something that Newton himself didn't like. So he didn't live that long to see it exploding in that direction. But had he lived that long, I'm sure he would not have been pleased, because basically what happened is that his way of thinking about the world had a very specific place for God. So he was a theist in the sense that in his view, God was a presence in the universe and interfered directly in the universe to make sure things stayed in order, that planets wouldn't crash into one another, that we would stay here. Because, you know, gravity being attracted is kind of a dangerous toy to have, right? Because imagine if gravity was really strong, if I had a button right here and I could change the strength of gravity, you just become a big ball of people in the middle of the room, right? Fortunately, gravity is very weak and that doesn't happen, right? But the point is that being a theory that describes how things work in the universe and here on Earth, what Newton did is, my theory works well to describe things, and that's all I care about. I don't know the source of where this is coming from, but that's good. right? For him, it was good. And then only later, Einstein in 1915 is going to come up with a new version of a theory of gravity, where instead of having this mysterious action at a distance, he's going to say that gravity has to do with the curvature of space due to the presence of a mass. So in the case of Einstein, you don't have an action at a distance anymore. You have a distortion of space, sort of like when you sit on a mattress and there's a depression around you. So because there is a mass there, so if you throw a marble close to the depression, you know the marble is not going to go on a straight line, it's going to go on a curved path. Well, that explains, according to Einstein, the way gravity is working. So he changed the whole thing into an action at a distance theory, which was what Newton did to this curvature of space theory. Right? Now, you may say that's tremendous, and in fact, it is one of the most beautiful theories. Some people would say the most beautiful theory ever developed by physicists. But if you ask Einstein, why does that happen? Why does space get bent by matter in this particular way? And not just matter, light can also bend space. Energy is matter, and so there is a deep relationship between all these things. And there is really no answer to that. Or if you ask Einstein, so the speed of light is the fastest speed in nature, 300,000 kilometers per second, or 186,000 miles per second, which is an absurd velocity. If you think about that, okay, we can't even contemplate what something like that is, but if you blink your eye, light goes 7.5 times around the Earth. So you go bleep, 7.5 times around the Earth. And it takes about 8 minutes, a little over 8 minutes, for light to travel from the sun to the Earth. 150 million kilometers, right? So if the sun exploded right now, Newton would say it's the end of the Earth immediately. Einstein would say, no, it would take 8 minutes. And then, of course, when it happens, poof, everything is over anyway, so who cares, right? But the point is that gravity propagates in space at the speed of light. But if you ask Einstein, but why is the speed of light that number? Why is it not a different number? You know, why is it not 500,000, kilometers per second? There is no answer. We don't know that. And so what we do is we create a narrative making measurements of the speed of light, of the strength of gravity, to sort of inform us about the universe. And in fact, the speed of light is actually very, very important to us, because actually what it's telling you is that the whole notion of nowness, is really a trick of your mind. For example, you may think that you're seeing me right now, but you're actually seeing me about 1 billionth of a second ago, because it takes about 1 billionth of a second for light to go from me to your eyes. But we think it's all happening at the same time, but it really isn't. The brain brings all this information together, right, and creates this sense of nowness. But that's somewhat of a different story, which has to do with cognitive neuroscience. I'm going to stick with the universe for now, because if it takes a billionth of a second for light to go from me to you, when you look at the night sky, you're actually never looking at things as they are. You're looking at things as they were. And the further away the object is, more into the past you are seeing that object. So for example, I told you about the sun being 8 minutes away from us. So you say the distance from between sun and earth is 8 light minutes. Well, the nearest star to the sun, the distance is about 4.5 light years away. And you say, wow, 4.5. So that means that when you look at that star, and it's part of a conglomerate of stars, and it's in the Alpha Centauri, there's Alpha, there's Beta, there's a bunch of them. They're about 4.5 light years away, which means when you look at that, you're really seeing it 4.5 years ago. So the night sky is a time machine to the past. And the farther out you look into the past, you're seeing objects which are farther and farther away from you, right? So this is a completely different universe from the universe of the Greeks, for example, who believed that the universe was sort of like an onion, with all the different layers. The Earth was at the center, and then you had all the planets, etc. And the outer layer was the sphere of these fixed stars. So they thought that all the stars were stuck in a crystal sphere, right? Just like, because it looks that way. It's a very kind of intuitive thing. You look at it and you don't see depth in the night sky, right? You only see this, but now we know that that's not true. There is depth. I mean, things go on and on and on, right? Now, just to give you an idea of how far 4.5 light years away is, if we picked up our fastest spaceship that we have right now, which can travel at roughly 30,000 kilometers per hour, it would take us about 100,000 years to get off of Centauri. 100,000 years. So why am I telling you this? I'm telling you this because when you look out there, the first thing you realize when you start understanding the distances involved is that there is a very fundamental feeling of cosmic loneliness here on Earth. You go to Venus, it's living hell. Venus may be beautiful to look at, but the reason why it's so bright is that it's so dense, the atmosphere, that it reflects the sun incredibly efficiently. If you go under the clouds, the temperatures are 400 or 500 degrees. It's so hot there that rocks glow. And it's full of sulfur, so it really smells bad. So it's hell. I mean, it's just like, it's sulfur, it's hot, things are glowing all the time. So Venus is only beautiful in the eye of the poets. If you go and you ask an astronomer, Venus is not a very good place to go spend your vacation. And neither is Mars, which is a beautiful but very, very dead, red desert. So when you start looking at that, and you start learning from modern science about what it is in the world that is special, what we can do now that we couldn't do a few years ago is actually look at planets going around other stars. There's a whole field out there, which is a beautiful field of exoastronomy or astrobiology, which is essentially trying to find Earth-like worlds going around other stars to see if there are other planets like ours. Why do we want to do that? Well, we want to do that because we believe that if life exists elsewhere, right, it will be in a planet that is kind of like ours. I mean, a rocky planet with a lot of water, not very cold, not very hot. We call it the Goldilocks, sort of proportion. It has to be just right for life to exist. So we're really eager to find if there is life elsewhere, right? But the point is that as we extend our reach into the universe, into the world of the very large, the universe, or into the world of the very small, with particles that we're looking at smaller and smaller components of things, one thing becomes very, very important, which is the knowledge that our instruments, they do expand our view of reality. I call them reality amplifiers. So a famous example, the microscope. So also in the wonderful 17th century, Van Leeuwenhoek in the Netherlands invented the microscope. And suddenly with that new instrument, questions about life or the nature of life or how big a living being can be changed completely. They actually became new questions that people couldn't have asked before, right? So this happens on and on and on in the history of science. We have a new instrument, a new technology that enables us to ask questions that we couldn't have even thought about before because they were so out there that not even in science fiction you could imagine that. For example, going back to the universe, the telescope with Galileo. So before Galileo, before 1610, all astronomy was naked eye. So people looked as well as they could and they measured as well as they could, but they actually couldn't see so much. So for example, they could only see up to Saturn. They couldn't see Uranus or Neptune because you can't see those planets with the naked eye, right? So their vision of reality was confined by what they could see. So they created a theory of the world based on what they could see. And then suddenly your vision of reality expands through a new instrument and you create a different worldview. You realize that there are other big planets out there. And then you realize that like in the 20th century, and this is really amazing to know, that only in 1924 we realized that our galaxy, the Milky Way, is not the only galaxy in the universe. Now let's remember what a galaxy is, right? So a galaxy is a big collection of stars. So the sun I mentioned is one star, and I talk about Alpha Centauri as our neighboring star 4.5 light years away. Our galaxy, the Milky Way, has about 200 billion stars. 200 billion stars. We are at and it's a big thing. Our galaxy is very big. It's about 100,000 light years across. So if you turn on a light, a flashlight or a torch, as you would say here, it would take 100,000 years for light to go across the galaxy, traveling at the speed of light, right? And so the Milky Way has all these stars, and now we know with this exoastronomy initiative that the vast majority of stars also have planets going around them. So we look at our solar system, right, with the 8 planets now that Pluto was unfortunately demoted, right? So he's not a planet anymore. He's a dwarf planet apparently. Although there's discussion of maybe, bringing him back up. Who knows, right? So it's kind of funny. But again, the definition of a planet changed because we got to know so much more about planets, discovering all these other ones. And so there are reasons for that you can tweet Jillian, to say, what's the story with Pluto? But the point is that all of those stars, or most of them, they have planets too. So in our galaxy alone, there are trillions of planets. And planets have moons. We have one moon. Jupiter has 64. Can you imagine the night there? 64 moons. And a lot of them are viable harbors for life as well. Well, not a lot, a few of them, especially in Saturn. There's one moon of Jupiter called Europa, which possibly can have life because it's made of ice. Essentially on the surface, it has like a crust of ice about a mile thick. Underneath the crust of ice, there is an ocean of salt water with more water, 4 times more water than all the oceans on the earth put together. So it's an amazing place. And so there is a mission, it's called the Europa Clipper, that is planned to go there and try to get some samples to see if we find some sort of interesting organic chemistry erupting or coming up from the surface of the planet of the moon. So the point is that you have planets, you have moons, and what we have learned is that each one of these is different. Each one of these planets has a history, and it's a different history. There are no 2 equal planet Earths in the universe. And when we learn about life, and it's interesting that the Christian Evidence Society was coming up during the Darwinian debate, about life. So when we learn about life, one of the fundamental things that we have learned about life is that changes in the environment sort of reset the whole life diversity. So, for example, 65 million years ago, a big asteroid hit the Yucatan Peninsula in Mexico and extinguished about 45% of life on Earth, including the dinosaurs. And the little mammals that were subdominant at the time had a chance to develop and become evolved, and lo and behold, here we are. Right? Now, if that particular cosmic incident had not happened, the history of life on Earth could have taken a completely different direction. And we wouldn't be here to discuss this. So there is a lot of contingency in when we describe these things. And it's kind of amazing that we're able now, scientifically, to construct a narrative of life on Earth. It's not a complete narrative. The questions of origins remain open. The origin of the universe remains an open question. The origin of life remains an open question. The origin of consciousness remains an open question. How is it possible that about 85 billion neurons connected by the synapses give rise to who you are? And you know that you are the same person tomorrow? What is going on here, right? So how is that possible? How is that going on? We do not know. So these are perfectly scientific questions that have very limited answers within science right now. So I mentioned the instruments, that they amplify our reality. But the very important lesson we learn from instruments is also that every instrument has a range, has a precision. They allow you to see farther out, but they don't allow you to see everything. There is always more to be seen out there. So in the very fundamental way in which science works, by using instruments to amplify the view of reality that we have, we know that there is a lot of unknowns that we cannot see with our instruments. And in fact, it's kind of interesting going back to Einstein, that another one of his quotes is that it's something that goes like this. To me, the most fundamental emotion you can feel is the mysterious. And he used the word the mysterious. It is the fundamental emotion at the cradle of science and the arts. And the person who does not feel that is as dead as a snuffed out candle. These are Einstein's words, meaning we have this capacity to ask those questions, to engage with what we can call the mysterious, which is precisely what science does on an everyday basis. We are always trying to make sense of what we don't know. What feeds science is ignorance, right? It's because we don't know that we have the curiosity to know more and more and more, and to keep asking questions as long as we have funding to do so, right? So we depend on that, unless you are like a lonely theorist, and those kinds of scientists don't really exist anymore. We're always working in groups, in collaborations, but the point is that the very backbone of science is an engagement, is a flirt with the unknown. And that is very important to keep in mind. And also to keep in mind that the answers that we get are always imperfect answers, because we don't have the complete map of the territory. Our instruments allow us to see some of the territory. So we're always surrounded by the mysterious, which I find a wonderful thing, because that means that you're always able to keep asking questions about the nature of reality, knowing that even if you progress further ahead, there'll be new ones, unexpected ones, that are going to be popping up right around the corner. And the ability to be surprised, I call it the simple beauty of the unexpected in one of my books, is absolutely essential, because it is what fuels our curiosity as humans. So the scientific narrative is one way in which we create or try to create some sense of understanding of all this mystery that surrounds us, right? But it would be wrong, and in fact it would be impoverishing to assume that it is the only way that you can engage with the mystery. There are other ways in which you can do it. You can do it through art. It's an expression of our feelings, our emotions that speak in a sort of a profound way about our searches for understanding and for meaning, right? And in the case of science and in the case of religion, you're also engaging with this unknown. But I wanted to go back to a couple of points. One of them is our planet, again. Because what we have learned about the history of life on this planet, and there are all sorts of amazing unknowns in this history of science, of life in this planet. One thing that we know, and we can affirm that for sure, is that we are the only humans in the universe. There are no other humans in the universe, because there will be no other planet with exactly the same evolutionary history as this one. So when people feel diminished by science and they say that, oh, the more I learn about the universe, these scientists keep telling us how trivial we are, how unimportant we are. Actually, I see it precisely the opposite. I see that the more we learn about the universe, the more important we are becoming. Because we are the only creatures, as far as we know, that are able to metabolize energy like animals do, but also to wonder about the mysteries of life and the mysteries of existence. And that makes us very important. And we also know that our planet is a very special place. There are no two other Earths. If there is one, it's so far away from us that we won't have any communication with them. So for all practical purposes, we are alone in this planet, where we are the only creatures that have the awareness of the importance of life. So can science bring up some kind of morality? Some people say, oh, science and morality are completely different things. Well, I would say that if there is one thing that we can talk about within a scientific context, from learning from what we are learning right now about the nature of our planet and the nature of life in our planet and the fragility of life in our planet and the fact that we are self-aware animals capable of understanding all this, is that there is one universal moral principle that kind of transcends all the tribal barriers that we keep banging each other against, right? I mean, the history of civilization is really a history of different tribes banging against one another for different reasons, right? Well, one fundamental one is that we need a new myth. We need a myth that transcends these limitations of the tribes that we subscribe to. And the only myth that I can see that has a unifying force is us as a species united to protect this planet and life in this planet. So I wanted to make that point tonight. The second point I want to make is that the very core of science, the way we can describe what's going on, is a metaphor that I created, and I found out that some other people before me had similar visions, which I call the island of knowledge. The idea being that if we can put all the knowledge that we have of the world in an island, as we learn more about the reality, as we learn more about nature and our place in it, this island grows. However, as every good island, this one should be surrounded by an ocean, and I call it the ocean of the unknown. So people say, well, you know, if you have a vision like some of the new atheists or scientism, you say, hey, it's a matter of time, science is going to conquer everything, is going to answer everything. Well, everything that I told you today tells you that that is absolutely impossible from a very fundamental way, which is the way science is done. That it depends on instrumentation, it depends on concepts that are ever evolving. So there is no end to this quest. And furthermore, as the island is growing, so do the shores of our ignorance, which are the boundaries between the known and the unknown. So that means that as we learn more about the world, we start asking questions that we couldn't before, right? So the quest is endless, and I find that's incredibly rewarding. And furthermore, if you start looking carefully in the ocean of the unknown, you find that there are some regions of unknowables there. Questions that you can ask within a scientific context that you cannot answer scientifically. And there are quite a few of them, which I don't have time to discuss today, but maybe you can ask later on as we talk. But it's very important to keep in mind that science, because it's a human creation, is not a God-given truth, is a human creation, is as fallible as we are, is as imperfect as we are. Does that take away the beauty and the power of science to create a narrative of the world? Of course not. In fact, it brings it out even more spectacularly because it becomes a reflect of our most fundamental and honest humanity. So to me, science is reaching out into the mystery to make us feel more human and not less human. And I wanted to share these ideas with you tonight. Thank you.
Professor Gleiser, thank you. I feel like I've been on a voyage through an island of knowledge. We've been into the history, we've been through science, we've been down to the tiny, smallest atoms, into the mind-blowing distances in our universe. And thank you for presenting also this idea of the open questions that are still, that we still have to deal with, the uncertainty, and that the science has no control over the knowledge. It's one mode of interpretation, perhaps inviting us all to be interpreters of the world around us. One of the ways that the Christian Evidence Society wants to help these religion and science debates mature and move on from conflict is to listen and to learn from science and to thinkers like Professor Gleiser, and then to engage with it and put it into conversation with our rich theological tradition. To do this, we are very grateful that the Reverend Dr. Andrew Pinsent has agreed to make a response, perhaps spend some time, if I can carry on your metaphor, spend some time at the boundaries or the shores of the island of knowledge. And Andrew is very well qualified to make a response. If you don't know Andrew, I'll tell you a little bit about him. He's the research director of the Ian Ramsay Centre for Science and Religion based at the University of Oxford in their theology faculty. He's formerly a particle physicist. He worked at CERN. He also has degrees in philosophy and theology and a second doctorate in philosophy. His publications include work in virtue ethics, neurotheology, science and religion, the philosophy of the person and the nature of evil. He trained for the ministry in Rome, the Venerable English College there, and was ordained priest in 2005, working after in a variety of parishes, both in the US and the UK. He is often in the media, in schools, and at lots of different venues. He's a regular contributor to this public engagement of religion and science. And Andrew, we look forward to your response this evening.
I reassure you, I've been told to limit my response to 10 minutes, so we can get into the debate as soon as possible. I thank Professor Gleiser very much for his work and for taking a more nuanced view of the relationships of science, philosophy and theology than the populist voices that often dominate the discussion. I also agree with much of what he says, and like him, I greatly value the sense of awe that is, I think, a typical, normal, proper response to the wonder of the cosmos. As a teenager, I was very inspired by the Voyager missions to the outer planets, which were themselves an extraordinary adventure and required many breakthroughs in mathematics and space technology. And every few years, a point of light in our telescopes would resolve itself into a world surrounded by other worlds, each one of which was full of mysteries and excitement. And these missions were one of the inspirations for me to become a physicist for several years, although I ended up studying inner space, particle physics, rather than astronomical objects. In conversation with others, I'm very aware that the encounter with the mystery of the cosmos can, in some cases, change a person's entire religious worldview. Several months ago in Chile, I interviewed Dr. Jose Hernandez, the first NASA astronaut from a Mexican migrant family. And the story of his endeavors to become an astronaut is quite extraordinary. He applied, I think, about 14 times, training himself in all kinds of different ways to finally be accepted into the astronaut corps. But what shocked him was actually going into space. His whole attention had been focused on becoming an astronaut, but when he actually saw the cosmos from above the atmosphere and all the stars directly in their glory, he said basically it changed his life spiritually. He left Earth as a nominal Catholic. He came back with a deep belief in the existence of God. So for him, going into orbit and seeing the stars was a spiritual experience, moving him to an explicitly theistic worldview. And the fact that this response is quite common in human beings is itself a source of wonder about ourselves. Now, I've long been fascinated by the fact that there are many animals on Earth with good eyesight. Take the owl. The owl has eyesight 100 times better than ours. And if an owl looks up at the sky, the owl will see 100 times more sensitivity, the stars. I mean, amazing things we don't see. But owls are not interested in looking at the night sky. They're only interested in small furry animals on the floor of the wood and catching them and eating them. So it's fascinating that we do more than these things. We look up, we want to see, and we want to wonder. And this wondering, which is a big theme of your talk, was recognized by the ancient Greeks. Aristotle begins his great work of metaphysics by saying we naturally desire to know. We naturally desire to know, and to know is to know causes. And wisdom deals with first causes and principles. There's a pattern to our investigations which is not sufficiently remarked upon or noticed. We seek an ever smaller number of ever more powerful causes. So in the history of particle physics, when we have a small number of particles to explain a lot of matter, we're excited. If the number of particles multiplies, as it did in the early 20th century, we look for the underlying patterns, we look for another layer of reality. An ever smaller number of ever more powerful causes. That forms a kind of pattern which you could call a funnel. And the funnel is, if you like, implicitly theological. Because whatever it is that is at the end of the funnel, whatever causes without being caused, is by one definition, God. So most of the battles between self-professed Christians and self-professed atheists normally are about the nature of the first cause. Now here I share a prejudice with Professor Gleiser. I don't like grand unified theories, because whatever causes without being caused cannot be a theory. Theories alone don't cause things. They describe things and predict things. So it might seem that the sense of wonder and the search for ever small number of ever more powerful causes would cause me to be a great enthusiast for natural theology. And certainly from my perspective, it can do some good. It can excite the mind. It can excite thoughts of wonder. It can often lead people to belief in God. But one of the paradoxes is that our technologies, our civilization, have both expanded our minds in some ways, but also have locked us in other ways. We're surrounded by artificial lights. We're surrounded with the shadows of the puppets of real things. The Plato's cave has now been moved to Hollywood. And we're so occupied, we can be so enticed by seeing the shadows flit across our electronic screens that we don't really look up at the cosmos. We don't really have a direct encounter with the larger world. I think being stuck in Plato's cave, updated in the 21st century, is a lot of the reason for the decline of philosophical reflection, of the rise of practical atheism in our society today. It's rarely the result of argument. It's much more the narrowing down of our direct perception and experience. I also think that the expanding study of the natural world in the late 18th century onwards helped to bring some sense of the divine back into the European consciousness, expressed in what Kenneth Clark called the Romantic Rebellion against austere classicism, all due respect to St. Paul's Cathedral. But I think one has to be careful what one means by God in this context. The universe may impress with its order. It may excite our wonder. But as you so eloquently pointed out, with many examples, it's very strange to us. It's a very hostile place for us. There are vast timescales. There are unimaginable spaces. We're overwhelmed with number, 100 billion galaxies, 100 billion stars each on average, roughly. We have extreme heat, extreme cold, extreme vacuum, extreme pressure. Radiation would destroy our bodies very quickly in open space near the Earth. So it's an alien place for us. We can make mathematical models of its behavior, but it still remains very alien to us. And this sense of separation, which you alluded to, the sense of almost loneliness, it echoes the rhetorical questions of the Lord God to Job in the Old Testament. Now, when people think about the Bible and creation, they think of Genesis, a sort of high Baroque vision of creation. But there's another story of creation which is so important, and it's towards the end of the book of Job. I'm very grateful to a physicist, Tom McLeish, formerly at Durham, now at York, for drawing my attention to these chapters. I want to read you a few verses. Then the Lord answered Job out of the whirlwind. Who is this that darkens counsel by words without knowledge? Where were you when I laid the foundation of the earth? Tell me if you have understanding. Who determined its measurements? Surely you know. Or who stretched the line upon it? On what were its bases sunk? Or who laid its cornerstone? When the morning stars sang together, and all the sons of God shouted for joy. Has the rain a father? Or who has begotten the drops of dew? Can you bind the chains of the Pleiades, or loose the cords of Orion? Now, in this rhetorical response of the Lord God to Job, it seems as if the whole point is to emphasize Job's ignorance, his smallness, but I think there's something more subtle going on. In this account, God relates interpersonally, intimately with his creation, but we're missing from the party. We're alienated from the party because of sin. And so hence God asks, where were you, to Job? This, of course, echoes the question to Adam in the book of Genesis, where are you? It's a strange question for God to ask if God knows everything. But I think it signifies the loss of the interpersonal relationship, the loss of the covenant with the man and woman. And this self-alienation is at the heart of the ultimate limitation of natural theology, as it was also limited in ancient Greece and Rome. The great philosopher Aristotle, inventor of biology, refers to God as good, eternal, and living, but never addresses God as you. We can get a sense of alien order, awe-inspiring order from nature alone, but the purpose and the personality of God remain ambiguous. From natural theology, we cannot gain second-person relationship with God in the manner of a spiritual marriage or covenant or friendship to end our loneliness. On the contrary, covenant with God comes to us by a different route, and in the light of this covenant, the universe is seen in a new perspective, giving rise to Judeo-Christian cultures that have ultimately proved very fruitful for science. On this account, natural theology is like the mysterious star described in the Gospel of Matthew, heralding the birth of Jesus Christ. The star doesn't carry the answers in itself, but it can act as a signpost, guiding pilgrims to the crib of the infant Jesus.
Andrew, thank you very much. We're now going to have a perfectly relaxed conversation. Can you see how we set it up in a relaxed way?
Under private conditions.
As I said earlier, one of the important aspects we want to draw out in the Christian Evidence Society is the willingness to go into conversation. But listening to you, Andrew, I was very struck with all the similarities really between what you were both saying. You both reference wonder, mystery, your dislike of grand unified theories, the importance of philosophy, but also loneliness as well. God's voice to Job, who is this that darkens counsel without knowledge? And given your agreement really on the limits of knowledge, the limit of natural theology, and the place of knowledge, I'm just wondering about our organisation, the Christian Evidence Society. The word evidence, do you think that's useful in these kind of conversations?
To a point, there's evidence for God from creation. Like the Greek philosophers, I think you can get to a natural knowledge of a first cause, and I think the whole heuristic that guides science as it's developed in a Western culture is very similar. So I talk about the cause funnel. An ever small number of ever more powerful causes guides our sense of the rightness of the direction of our investigation. But you don't get the personal knowledge, and this is where the best you can do, I think, is something like a hypothetical deductive method. If this is true, what follows? And what the history of Revelation has done is give us a narrative, a very positive and encouraging narrative. You've got the Logos, order. You've got a God of love. That changed the way we looked at the world in ways that ultimately proved fruitful. So I would say by their fruits you know them. I don't think it's evidence in terms of a deductive method, but I think there's a fruitfulness in the way that our culture has been in respect to the natural world. And funnily enough, I call as supporting evidence for this, in his absence, Richard Dawkins, because even Richard Dawkins is surprised at how many Nobel Prizes the Jewish people win. It really is quite amazing, about 170 Nobel Prizes. But they were the first people to have a sense of covenant with God. And I think they look at the world differently as a result. And so it's so you might say it stands out like a sore thumb as something strange in the world. But of course, picked up and recapitulated in the history of Christianity.
Well, so I mentioned before that there are some questions we can ask scientifically, but we cannot answer scientifically. And of course, one of them, you mentioned the first cause, which is perhaps my favorite topic, because it's the most mysterious of all of them. The notion that we all would love to know how the universe came to be, right? How did this happen? How did the Big Bang bang, so to speak? But we really don't know. And more than we don't know, it's we cannot know. At least we cannot know from the usual way in which scientific theories describe the universe. Because the way we describe the universe in science is we need a whole conceptual framework to explain what's going on. So science doesn't come out of a vacuum. It comes out of concepts like space, time, energy, laws of conservation of energy, laws of conservation of angular momentum, which is rotation. And all of these things are necessary for us to create a narrative of the origins. So the question then becomes, can you come up with some clever model that would describe the origin of the universe? Yes, there are quite a few of them out there indeed, but they all depend on some very fundamental, unjustified assumption.
So staying on that subject, we've had 2 questions come through on Twitter. And remember, if you want to tweet a question, it's Drawbridge 2018, I'll pick it up. 2 questions have come through that really relate to what you've just finished by saying there. Somebody's asked, therefore, about the attraction of the God of the gaps theory when it comes to having a closed system. And also, slightly different, the anthropic principle. And I'm sure not everyone here knows what that is, but perhaps one of you can explain that before answering and critiquing the anthropic principle as a closed model that some people find attractive.
So the God of the gaps is just this strategy, which I find is a very bad one, that basically it says that if you cannot explain something scientifically, it's because God did it, And for example, Newton, when he was describing the way the moon goes around the earth, people say, but how did it start going around the earth? Well, it had an initial push from the angels. So that was a God of the gaps idea, right? And of course, that is just not true. That is not what happened at all. So it is dangerous because if you're going to base your faith, here I am explaining faith to you. If you're going to base your faith on assumptions about what science cannot explain, you're going to live very perilously indeed, because if science advances and you start having new knowledge about something, your God is going to be squeezed more and more. So if you want to really find a place for God in life, I would not look at those unanswerable questions.
Just follow up a little bit on this, because I also don't like a God of the gaps. But when we talk about limits of science, we're talking about different kinds of questions that scientific method can't make progress on. And in fact, I'll pick up an example you used in your talk, which is Pluto a planet? Which is fascinating because it looks like a scientific question, but you can make all the measurements you like. But you have to make a judgment of reason. Does it belong to this class of objects or another class of objects? So we have to bring in reasoning processes which are not just about scientific method. And it's quite funny because astronomers around the world had to go back to ancient philosophy, species and genera. It was really they had to become Aristotelian philosophers for a few years as they debated the status of Pluto. So there's more to even ordinary questions than scientific method alone can handle. We need philosophy as well, particularly to know what things are rather than just how they behave under experimental conditions.
So what about this for a question for you, giving our focus on unknowables? Thomas has tweeted to ask, one of my friends believes that the discovery of alien life would be the definite death of religion. Yet we know alien life is likely, he says, considering the size of the cosmos. What are your feelings on this?
Quick one on that one, because C.S. Lewis wrote such a fantastic essay on this subject. I'll just quote it. Religion and Rocketry. You just go look at Religion and Rocketry by C.S. Lewis. Best last word to be said about that. Theology would just become more exciting for the Radians.
Yes, I mean, why would God not do something, right? I mean, that's really the question. I mean, you know, if God basically is omnipresent and perfectly powerful, you know, he could create whatever life form he would like to anywhere else.
I think the real question is practical. We want to be careful not to meet aliens who are far more intellectually advanced, technologically advanced, suffering badly from the effects of original sin, and able to smite us very hard. That would not be good.
So this was a conversation that was held, you know, before the 1600s. You know, Giordano Bruno asked questions like this. So he said something like, well, all other suns out there may have people in planets going around them, and the question of would they be sinners as well, right? And if they were, would they need a savior? And would it be the same Jesus that was here? Would there be many Jesuses? How would that work? You know, so that was a very confusing, I guess, theological, and I don't know exactly what the resolution is, but this is not a new question. Let's put it that way.
Professor Gleiser, you mentioned Heisenberg in your talk, one of the greats of the development of quantum science, and he's got a very famous quotation that often comes up in science and religion conversations. He wrote that the first gulp from the glass of natural sciences will turn you into an atheist, but at the bottom of the glass, God is waiting for you.
Ooh,
helpful or patronizing?
Well, you know, I think that it's, again, how we humans deal with unknowns. And I think it's a very personal choice how you do that. I think in his case, he's basically saying that, yeah, you know, I'm a brilliant scientist, and yes, this sort of most obvious approach to science is to follow this atheistic kind of route. However, when you start to deal with the real fundamental questions, you realize that you don't know how to answer them. And then you have a choice that you're going to make, right? Which is, how do you deal with doubt, right? And you can deal with doubt through faith in some God, like, you know, or you can deal with doubt by accepting ignorance and living a life knowing that, yes, there are some things that you just won't know, and that's okay. It doesn't make you less complete as a person. So I think that at that point, whatever you find at the end, at the bottom of the glass, is something that is going to depend very much on choices that you make in life.
Let's just add a comment here. So a little personal anecdote. When I studied at Oxford for my undergraduate degree, I was taught by one of my tutors was exceptionally brilliant man, but he did have this kind of very skewed way of looking at the world. I remember him saying to me, if you can't measure it, it doesn't exist. If you can't measure it, it doesn't exist. Now, I would challenge him today, talking about so many things we cannot measure, which, you know, artistic beauty, music, and there are ethics, all kinds of things, which are aspects of ordinary everyday life, even before we get to God and the soul. Which are so important to us as human beings. So we've got to be careful. Scientific method is a fantastic tool, but if it becomes exclusive, then it risks becoming, if you like, not only excluding God, but actually excluding our own humanity, and that's that can be very dangerous. By the way, the anthropic principle, we didn't address that question.
No, we didn't, yes. Can we go back to that?
Do you want to go back to that one?
Yeah, please. Yeah.
Sure. Well, you brought it up. Let's see what you say.
First of all, it's a lot of fun, and it's got concrete predictions. So people started speculating, what kind of universe do we need to have to exist ourselves? And then, when we've considered the range of possibilities, it seems that only a very small, narrow range of possibilities for us to exist. So stars, if you change the ratio of electromagnetism and gravity very slightly, you wouldn't have nice, well-behaved yellow stars. The entropy conditions are quite extraordinary. And, Big Bang. Who's the not the man who gave the name?
Fred Hoyle.
Fred Hoyle. Thank you. I'm a bit rusty, sorry. Fred Hoyle, because actually said, well, it seems like someone's monkeyed with the laws of physics. And he was excited by the resonance that enables carbon to exist, because it is so remarkable in the nuclear cooker of stars and so on. So, anthropic principle. The universe does seem to be fine-tuned, and as we've learnt more, the tuning seems more remarkable. There's not really a big bang, there's a big bloom. Like an explosion producing an airliner, that sort of thing. But we don't really know what to make of it. And I think theologically I'm a bit suspicious we shouldn't rest too much on this. But it is a remarkable thing, and it's still one of the, at the heart of one of the biggest mysteries in physics today. Why do the constants have the values that they do?
So just to complement that, so there are different versions of the anthropic principle. There is the strong and the weak anthropic principle. In the strong anthropic principle, basically the idea is that it's not just that we are here because the constants of nature were tuned in order for intelligent life to exist. We are here because the universe willed it so. So meaning there is a teleology, a sense of cosmic purpose. So the universe has some sort of like intelligence and essentially designed us to be here, right? So that is one. I'd love to hear how you respond to that. But before we go there, then there is the weak anthropic principle that says, you know, the way we do physics, I actually mentioned the force of gravity, right? So if you tweak the force of gravity, I was actually playing with you, say if you make it stronger, then you would all ball up, right, and become a ball of people. And the reason why we're here is because gravity is a very weak force with a certain strength. And so the whole way we describe nature depends on a set of fundamental constants. One of them, the other one I talked about was the speed of light. So there you go, you have g, the gravitational constant, c, the speed of light. And the question is, if you tweak with some of these constants, as Andrew was saying, you'd really change the way stars shine. And if you change the way stars shine, you can't make chemical elements because stars are the real alchemists. They, you know, when people say that people, who are we, you know, and so one jokingly answers that we are what happens to hydrogen if you wait long enough. Because that's exactly what's going on. You know, everything starts with hydrogen, and then the stars make it into helium, etc. And you fill up the whole periodic table of the elements. And so the question is, why do the constants of nature have the values that they do? And there's a big split in the scientific community about, is this a valid scientific question or not? And I tend to side on the group of people that say this is not a valid scientific question. And one of the ways in which people try to justify this is using the multiverse, which has its own theological interest.
So let's stay with that, because we had a tweet through right now about multiverse from Nigel, and he's asking, to what extent is multiverse theory a metaphysical attempt to do away with the need of a creator? How much of it is science, and how much of it is a way people deal with uncertainty?
Yeah. So there is he's here in London, I think, Bernard Carr, who made a statement which I think is somewhat outrageous. It says, if you don't want God, you want the multiverse. I don't know if you heard that before. And the reason for that is that if you start saying, wow, you know, nature is tuned in such a spectacular way that God was the tuner, or, so that's unique God, or there are a multiplicity of universes out there. Ours is not the only one. And all these different universes may have constants of nature with different values. And it so happens that out of this tremendous, huge statistical sample of universes, ours is the one where things worked out okay. So that is the reason for that, right? And the problem with all this is that, as Nigel, you said the name, is that the multiverse, talking about things that you can measure. So the multiverse, you really cannot measure, okay? Because by definition, so you do not know if the multiverse exists or not. And the worst part is that it's not that you do not know, you cannot know, because all the information we can have depends on how fast light travels. And since the universe has a history, it started 13.8 billion years ago, we live in a bubble of information, which is as big as the distance light has traveled since the beginning of time. And that means that anything which is beyond this bubble of information, so we're like fish in a fishbowl, so to speak. So anything beyond that is inaccessible to us. So we just cannot know if the universes are there because, in a fancy word, they are causally disconnected from us. So what is this, right? I mean, and there is a huge debate, and I have to say, I just wrote an essay for Nature that came out a week ago on this issue, you know, and I mentioned, talk about an unknowable in science, this is a big one. And so science is going, especially theoretical cosmology, is going through this very interesting period where for the first time, we have a hypothesis, which is a scientific hypothesis. There are reasons why people propose the multiverse. It's not coming out of nowhere. There are motivations for that, which we actually do not know how to verify that. So what do we do with this? Again, two teams. One of them is, forget about it, that's not science. The other is, let's play with the idea and see what we get out of it. Maybe we're going to get some interesting information that will advance what we know about our universe.
A couple of brief additions to this, one of which it really touches on a point I made in my brief talk about the argument between a self-declared theist and atheist is often over the nature of the first cause, that which causes everything else without itself being caused. So I think it can act as a kind of part of a creation myth. I think it can act as a God substitute in the minds of many. But you see, you get back to the uncaused cause, something which causes everything without itself being caused, which is eternal, which satisfies the job description of God in a natural theology. The question is whether God is personal. That's always the interesting one. But one more point about the multiverse, which is that it doesn't, although some people claim it solves problems, if the universes are causally connected, then you've got a philosophical question, are they really different universes? Then some problems get worse with fine-tuning, don't get better. So you've got to be, it's not a sort of get-out-of-jail-free card for these problems.
And just a final comment on this. So this week, like a few days ago, there was a new discovery where some astronomers found out that life can exist in the universe is not just expanding, it's accelerating. So there is this thing called dark energy that is pushing the universe apart. And people thought that life is only possible if this dark energy has a very specific value, range of values. And what these people have found out is that that's not true. That actually you can have a huge variation. And that would weaken the whole idea of you need a multiverse in order for the universe to be the way it is. So maybe we can rule it out.
All open questions, but a lot of fun.
Yeah.
I'm going to ask one last question before we move to our drinks reception, take us right back onto this planet. And I want to ask a question about education. From primary school onwards in this country, many children have the impression that they have to choose religion or science. Even really young children are faced with this question, and it of course goes through adolescence, and many adults think you also have to choose. If a school-age child asks you, do you have to choose religion or science, how would you respond to them?
Well, you've got to start teaching philosophy from a young age, so they don't put into these false questions. We don't teach children how to think. Children are natural philosophers. They ask why questions. And the first question, and then the response to why is because, the cause of the being of a thing. And as they grow up, they change to how questions and how much. You'll get back to why questions. But they're frustrated because they're not taught how to think. They're taught little compartmentalized subjects with facts and a sort of falsely complete view of the world within each of these silos. So there's a bigger problem here. Although this is a very important symptom, which is the need to teach proper philosophy and practice the real thinking and questioning skills.
I agree, 100%. And I would add that you should also teach history of science.
Yes.
Because if you learn how science actually evolved in time, a lot of these problems would disappear.
Yes.
You know, but people don't. They learn about the laws of Newton, how do you solve these problems without knowing anything about who Newton was and why was this happening in the 1680s, you know.
And always remember that genetics and the Big Bang Theory were first proposed by priests. So Lemaitre and Mendel. So the story is much more interesting than some people portray.
Great. So the story is much more interesting. That's a great place. I'm very sorry to have to artificially, it feels, draw the conversation to the end. We have a drinks reception behind you, back the way you've come. So we've videoed this event tonight, and we'll put it on the internet, on YouTube. So do tell your friends about it. Do look at it again. Perhaps it'll raise more questions for you going forward. I really hope you've enjoyed this event. Thank you for coming. I hope you've got something out of it. It just leaves me, before we head that way for some drinks and hopefully more conversation, to thank our speakers tonight, for Marcelo for the wonderful lecture, Andrew for responding to it.